So this video is about balancing equations 2, and it's slightly more complicated balancing equations. For this first one, C3H8 plus O2 yields CO2 plus H2O. I'm going to give two tips here. First off, if you can, balance hydrogen and oxygen last. That doesn't work every time, but often that'll save you from having to go back and fix other things and might make it more simple the first time. And then the other tip is watch out for elements that are split into different compounds. Notice that oxygen shows up here and here on the product side. Don't forget to count both of those spots where oxygen is located. All right, so we'll start by counting up our atoms on each side of the arrow. On the left side of the arrow, we have 3 carbons, 8 hydrogens, 2 oxygens. On the right side, 1 carbon, 2 hydrogen, and 1, 2, 3 oxygen. You just add those up. Now this is a spot where you might look at oxygen and say, oh, 2 and 3, let's try to make those both into 6. But because oxygen is split across 2 separate molecules, that's not the best plan. We're going to save oxygen and hydrogen until the end, and we'll start by balancing carbon. 3 carbon here, I want a 3 over here, so I can put a 3 in front. Now I have 3 carbons. 3 times 2 is 6 oxygen, plus this guy over here, that's 7. I'm going to do my hydrogen next. So 8 and 2. I'm going to try and put something in front of here that will give me 8 hydrogen. Well, that's a 4. 4 times 2 is 8 hydrogen. Well, 4 times 1 is 4 oxygen, but don't forget about these guys over here. 3 times 2 is 6. So 6 plus these 4 is 10 oxygen. Carbon is balanced, hydrogen is balanced, oxygen has 10 on this side, 5 on this side. I want to put a coefficient in front of O2 that will give me 10 oxygen, so I can put a 5. 5 times 2 gives me 10 oxygen. And now this equation is balanced. Remember that if you're typing your answers in to positive chemistry, if there's a blank spot for a coefficient, you just type in 1, because that means 1 molecule is present. Let's look at one more problem. This one looks complicated, but when we break it down using a trick that I use, it's actually pretty simple. PbNO32 plus K2SO4 yields PbSO4 plus KNO3. This is something I do that you don't have to do, but I find it makes it easier. If you notice that a polyatomic ion is present on the left side and the right side, it's not broken into pieces. It's not like this nitrogen gets bumped out and there's an extra N2 over here. If you see that it's present on both sides, I like to write it as just one chunk down here. You can see I did that for NO3 and for SO4 for sulfate. I wrote that down here. You'll see as you work through these equations that polyatomic ions often stick together on both sides. If they don't stick together, then this doesn't work though. You can still balance it without doing this, it just gets more complicated with all those oxygens. All right, so here's how we would count up the number on each side. So here's our arrow. For lead on this side, we have 1. For nitrate, NO3, there are 2 NO3s, because this 2 says everything in the parentheses, we've got 2 of it. So 2 NO3s. 2 Ks. And SO4, there's not 4 of them, because that 4 is part of sulfate. So SO4 altogether, there's just 1. on the product side. We have 1 lead. SO4 does not have a parentheses with an extra number out here, so there's just 1 sulfate, 1 potassium, 1 nitrate. Well, now you can see that the only unbalanced species here are K and NO3. So if we want to get 2K and 2NO3, we just put a 2 right here, and that's it. Now it's balanced. 2 Ks and 2NO3. And you would just put a 1 in each of these boxes if you're doing this on the Positive Chemistry website.